Hello, today I want to discuss about a geometry problem that appeared in INMO 2021. We will solve them using well-known trigonometrical identities, some angle chasing, and sine rule. See, there are a lot of hard geometry problems, Olympiad geometry problems that can be easily solved using these trigonometrical tools. These are really important. So this will give you a general idea to how to solve geometry problems using these trigonometrical tools. So the question says we have a convex quadrilateral ABCD. Angle ABD is 30 degree, angle ACB is 75 degree, angle ACT is 25 degree, CD equal to CB. We extend CB to meet the circumcircle of triangle ACD at E. We have to prove that CE equal to BD. Let's do this out.
This video is sponsored by Chinta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
The key idea to solve geometry problems using trigonometry, we have to first do some angle chasing. Like we have to define some variable for some unknown angle and we have to express the other angles as a simple function of that angle. Then we can use sine rule, cosine rule, or other well-known trigonometry like triangle related formulas to get some trigonometrical equations involving that angle, and we have to solve for that angle. So in this diagram, this is my main geometrical diagram, we have to do some construction. We join E with all other vertices. Like initially E was connected to C, but E was not connected to all the other vertices. We join E with all the other vertices. This will help a lot in angle chasing. We define angle BDE to be theta. Now some simple angle chasing gives me angle CAD to be 40 minus theta and angle BAE to be 5 plus theta. In triangle ADC, we know angle ADC, angle ACD, and from that we can easily get angle CAD. Quadrilateral ADCE, this is cyclic, and in any cyclic quadrilateral, sum of complementary angles is 180 degree. From that we can easily get angle BAE. And there are a lot of simple angle chasings that helps us to find all the other angles. Using by doing all this angle chasing, we get this diagram. Now we'll try to solve for theta. For that we have this information that CD is same as CB. We have to use that information out. For that we'll use these two triangles ADC and triangle ABC. We'll use sine rule on both these triangles. So let's do this. So sine rule, what does it give me? In triangle ADC, I want to find DC by AC, these type of ratios. So CD by AC, opposite angle of CD is in that triangle is 40 minus theta and AC is 75 plus theta plus 40, that is 115 plus theta. So this is sine 40 minus theta by sine 115 plus theta. In the second triangle, like triangle ABC, we get BC by AC 35 and 30 plus 40, 70, 35 and 70 degrees. So BC by AC this is sine 35 degree by sine 70 degree. And sine 70 degrees 2 sine 35 cos 35, so this is just 1 by 2 cos 35 degree. And using the previous relation that CD equal to BC, we can easily get an equation. CD equal to BC, and these two equations gives me directly one relation. 2 sine 40 minus theta cos 35 degree. Okay, this is same as sine 115 plus theta. Now 2 sine A cos B is same as sine of A plus B plus sine of A minus B. So this is sine of 75 minus theta minus sine of theta minus 5. Like it was plus sine of 5 plus sine of 5 minus theta. So this is minus sine of theta minus 5. And this is the sine 115 plus theta. So from that we get sine 75 minus theta equal to sine 115 plus theta plus sine theta minus 5. And using the formula that sine C plus sine D equal to 2 sine C plus D by 2 into cos C minus D by 2. From that we directly get that this is 2 into sine of 55 plus theta. 115 minus 5 by 2, this is 55. 55 plus theta into cos 60 degree. And cos 60 is half, we know that. So this is just sine 55 plus theta. So sine 75 minus theta is sine 55 plus theta. So from that we get 75 minus theta equal to 55 plus theta. Like sine alpha equal to sine beta would imply either alpha is beta or alpha plus beta is 180. The second case is like it is illogical here because that would give me absurd things. You can easily check by yourself. So first case is the only possible case. So from that we have 2 theta equal to 20. So theta is 10 degree. After we get theta 10, now we have to show that C equal to BD. Now we try to express C and BD in terms of these trigonometrical things. We can just use directly sine rule, like CE by sine of angle CDE. This is 2 times circumradius, and this angle is just 40 plus theta, and theta is my 10 degree, so this is 50 degree. So CE toward times sine this angle CDE, and that is 50 degree, like 40 plus theta. So this is towards sine 50 degree. I have to express BD in similar form. Now to directly get, we have to express BD in relation with some other side length, that is side of a triangle, that triangle which is inscribed in the circle, else we cannot get the circumradius R. So we'll use triangle BCD for that, and side length side DC. So we'll use the side length ratio BD by DC. What is BD by DC? BD's opposite angle is 75 plus 25, that is 100 degree, and DC is 40 degree. So BD by DC is sine 100 degree by sine 40 degree. By sine 40 degree, and sine theta is same as sine 180 minus theta. So sine 100 degree is same as sine 180 minus 100 degree, that is sine 80 degree by sine 40 degree, and sine 80 degree is 2 sine 40 into cos 40. So this is just 2 cos 40 degree. So BD equal to 2 into DC into cos 40. And cos 40 is sin 50, we know that. Now what about DC? This is just 2 sin 50 into DC, okay. What about DC? We use triangle ADC to find DC in terms of some sine of some angle into R. So by sine rule in triangle ADC and angle 40 minus theta, that is 30 degree. DC by sine, DC equal to 2R into sine of angle CAD. DC equal to 2R sine of angle CAD, and that is 40 minus theta. This is 40 minus theta, that is 30. So this is 2R sine 30 degree, and sine 30 is half, so this is just R. So from that we get what? BD is 2 sine 2R sine 50 degree. BD is 2R sine 50, and we also found that that is same as CE. CE is also 2R sine 50. So BD equal to CE, and that is what we have to prove. And this ends the solution, and we are done.
Chinta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Chinta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit chinta.com.